Okay, so the last couple days we've talked about covalent bonding with the electron dot diagrams, and we've talked about ionic bonds and how to form ions was yesterday. So today we're kind of putting the two of them together, and we're going to talk about polyatomic ions. And we're also going to talk about transition metals, kind of thrown in there. All right, so actually we're going to talk about transition metals first, but this is real quick. So transition metals are this group of metals here in the middle of the periodic table that up until now we've kind of ignored when we've talked about valence electrons and how to form ions and all that. And the reason we've ignored them is because they don't cooperate. They don't follow a set of rules as easily as these other columns do, where we can say, all of the elements in this first column have one valence electron. That doesn't work in here. These guys have all different kinds of valence electrons, and they can even have different numbers of valence electrons and form different ions depending on what they're bonding with. Right? So when you are using these in ionic compounds, which does happen pretty frequently, you've got to pay close attention to which charge and which ion state you're using. All right, so like most other metals, the transition metals, hold on, shrink myself down there. The transition metals tend to form positively charged ions, so they are usually the cation. They like to give away electrons rather than take electrons from other things. And they can give up different numbers of electrons depending on what other atoms they're bonding with. All right, so those different ions that they can create with different charges are called ionization states. And you'll differentiate between them by using Roman numerals, or I will when I tell you which type of this metal you're using for a given problem. So you can see here iron with a 2 in parentheses, II, Roman numeral 2, would be an iron atom with a charge of positive 2, so Fe plus 2. And iron 4 would be an iron atom with a charge of positive 4. All right, so anytime I give you a ionic compound problem like this that is asking you to use transition metal as your cation, I will tell you which ionization state to use, and these Roman numerals will let you know what the charge of that ion should be. All right, so you won't have to worry about trying to figure it out on your own. You just need to know what it means when you see something like this. Okay, so moving on from transition metals, our other big topic for today is polyatomic ions. So this is what I was talking about, kind of tying together the covalent bonding that we talked about with the electron dot diagrams with our ionic bonding. So polyatomic ions are covalent compounds that, instead of being neutral overall, have an overall charge. So they form an ion on their own, even though they are made up of covalent bonds. Most of them have a negative charge. They're mostly anions, but there is one or two that are positive charges as well. So you can have a polyatomic cation. You just have to pay attention to what the charge is on them. All right. When they're written as an electron dot diagram, like you see down here, you should draw it out just like you would any other electron dot diagram, and then put brackets around it and put the overall charge outside of the brackets. So if we were going to draw the electron dot diagram of cyanide, which is a polyatomic ion, the formula for it is Cn minus, so it's a carbon and a nitrogen bonded together that have an overall charge of -1. And that overall charge of -1 lets you know that it should have one more electron than it would usually, right? So if we did this just like our normal electron dot diagrams, we would go through and we would say, okay, if we find nitrogen on the periodic table, it should have a total of 5 valence electrons. If we find carbon on the periodic table, it should have a total of 4 valence electrons. So if we add those together, we should get 9 overall to work with. And if we go through and we count on here on our drawing, we have 2, 4, 6, 8, 10 total. So if we were only supposed to have 9 and we've used 10, that's where this negative charge is coming from, because there is one more electron than you should have, right? So the homework for today is going to be both drawing these electron dot diagrams for some of these polyatomic ions. So you can see, like this one here, it would be, the question might say, draw the electron dot diagram for ammonium, which is NH4. So if you go find how many electrons a nitrogen atom should have, it would be 5 from the nitrogen, and then each of these hydrogens would have 1 overall. So 5 plus 1 from each hydrogen, and there's 4 hydrogens, so that's 4. You should have a total of 9 electrons. If you go through and count 2, 4, 6, 8, you've only got 8. So if you have 1 fewer electron than you should, that would give you an overall charge of positive 1. So that's what they've drawn here. It's got the brackets around it, and it's got that overall charge on the outside. All right. So it can ask you to do this. The homework might also ask you to use those ionic compounds to create ionic bonds like we were doing yesterday. So it might say if you've got ammonium, which is this NH4 plus, and oxygen, what would the overall ionic compound that it would form look like? So if ammonium has a positive 1 charge, and we know from the stuff we did yesterday that oxygen should have a negative 2 charge. Let go, Fisher. Sorry, my dog is messing around over there. So ammonium has a positive 1 charge. Oxygen, get down, bud. Oxygen has a negative 2 charge. In order to balance those out and make the entire compound neutral, you would need 2 ammoniums for every 1 oxygen. So when you wrote that out, you would say your ammonium with parentheses around it, and then the subscript 2 to tell everyone that there are 2 of these for every 1 oxygen. So this would be your formula for the ionic compound. Same as you were doing yesterday, just instead of using the 1 element ions, now you're using the polyatomic ones. All right, so again, just like yesterday, the homework you can do by drawing it out by hand, which might be easier for some of these electron dot diagram ones, or you can do it on the computer and then submit it as a text file in Canvas, whichever one y'all are more comfortable with. Okay. The other assignment for today, after you get this done, is an Edpuzzle video that talks about metallic bonding. And that will be our last kind of type of bonding that we talk about. And then we'll move on next week to naming compounds and that sort of stuff.